A spring is an elastic system. This elastic system is a system that is deformed by a force. The force in order to deform this spring is given by Hooke's law, which states that the force is proportional to the deflection or the deformation. We have a constant of proportionality, which is the elastic constant K, given in Newton per meter. It's the amount of newtons you have to input the system in order to deform or deflect 1 meter the spring. If we graph force against the displacement or against the deflection, we will see a straight line whose slope is the constant K. At the beginning, the position it has is going to be called the equilibrium position. Then you can actually deflect it by another portion. If we want to get the work in order to deflect the system, this is going to be equal to the addition of forces times the displacements in x. Having the straight line as force and of the graph force and displacement, we can actually get the work as the area below the curve in this graph. Given this is a triangle of base x, which is the deflection or displacement, and the height force, which is equal to kx, this is going to be given as 1/2 of kx squared. This is because it is a variable force. Other variable forces will have the same work, the area below the curve. If we do the graph force and displacement, we can actually get the area below the curve of these systems, and that is going to be its work. This work then is the integral of force in a dot product with the displacement. Springs then are systems that are going to produce some work. If we have the system and we deflect this system from its equilibrium position, then we will have some work. Work which is stored is going to be called energy. It's a potential to perform a work. Then we will have the potential gravitational energy as the potential for the gravitational force to perform a work, that is given as mass, gravity, height. The potential elastic energy is the potential for a spring to perform that work, that is given as 1/2 of the elastic constant x squared. Let's remember that work is going to be equal to a change in kinetic energy. This will lead to a conservation of energy. If the work performed by any of these given systems, the elastic or the gravitational system, is then turned into a kinetic energy, then we can actually state that this energy is going to be conserved. The conservation of energy states that the potential gravitational energy at the beginning plus the potential elastic energy at the beginning plus the kinetic energy at the beginning minus any given work performed by friction is going to be equal to the potential gravitational energy at the end plus the potential elastic energy at the end plus the kinetic energy. For instance, if you have a particle which is at some position from height equals 0, this has a height, it has the potential to perform a work because of the potential gravitational energy. If you analyze the particle at any given height, let's say this height, this one has a potential gravitational energy. At another height, it has a potential gravitational energy higher than the previous one. This is stated is a conservative force. It is conservative because no matter what happens, if you're at the same point, you will have the same energy. Conservative forces are weight with its potential gravitational energy, elastic force with its potential elastic energy. It only depends on the system, where on the system you are. Non-conservative forces are the ones which lose energy. That could be friction. So the system that is in friction loses energy due to friction. It could also be air resistance.